I think we move back to Ireland again, and the next talk is by Rebecca Carroll that will talk about biases in classifying Fasciola hepatica infections.
Thank you very much. Just before I begin, I'd like to acknowledge the people that helped with this work. Dr. Andy Forbes, Dr. David Graham from Animal Health Ireland, and Dr. Loxley Massam from UCD. Sorry, so I suppose just to give you a little bit of background as to why we decided to do this work and develop these protocols. I work for Animal Health Ireland, and we have recently developed a new beef health check programme. So this programme is involved in capturing abattoir data and reporting it back to farmers. We're mainly looking at liver and lung lesions, so liver lesions related to liver fluke and liver abscesses as well, and lung lesions related to pneumonias. So I suppose because we're collecting this data, we're interested in looking at prevalence information that can be taken from this data, and I suppose we're very concerned about the accuracy of the disease prevalence estimates. So I suppose the problem with abattoir data is that it's not collected for research purposes. The reason that abattoir data is, or the reason that meat inspection is conducted is generally for a public health or for food safety reasons. Abattoir data may be used to estimate disease prevalence, but it isn't its primary purpose. So I suppose the issues that we see with that then are that disease prevalence may be estimated for undefined target populations. Often the disease prevalence is just estimated for the abattoir population, and a specific concern isn't taken to what population you're actually interested in, so what target population you want to refer the information to. The other issue is that there can be an issue with disease misclassification. So diseased animals may be identified as undiseased, or undiseased animals could potentially be identified as diseased animals. So we wanted to create some protocols to reduce the possibility of these biases. So we set ourselves the objectives of creating a flowchart for abattoir surveys estimating disease prevalence. And the first one will look at identifying target and study populations, and the second then looking at identifying and correcting sources of disease misclassification. And I suppose if any issues or deficiencies are found in an abattoir survey through the use of these flowcharts, then that will facilitate the reporting and discussion of any limitations. So first of all, just to look at the first flowchart, and we're looking at identifying and minimizing inconsistencies between the study and target populations, and allowing the generalizability of the results of an abattoir survey. So first of all, just to look at the target population. The target population is the population that you're actually interested in. So that's the population that you want to identify a disease prevalence for. The abattoir population obviously is the animals in the abattoir that you've got. So that might be one abattoir, might be a number of abattoirs. And then the study population is where those two populations overlap. So the population that represents your target population, so your population of interest. You may have to exclude some animals from your abattoir population in order to find your study population, or you may even have to add in some animals from your target population into that study population as well. So then just to go through the questions that we created, I'm going to go down through the list of questions first with just the yes answers, and then look at if there are any negatives. So first of all, we have to define our target population. Target population needs to be defined in terms of animal characteristics, location, and time. So I suppose while we're here, I'm going to take a very simple target population and just look at one farm. Obviously, in most scenarios, a target population could well be something much bigger than that, particular animals, particular groups of animals in a regional area, or possibly even on a national scale. But for this, we're just going to take a very simple example and look at just one farm. So once we've defined our target population, select our abattoir. And then we make sure that there are target population animals in the abattoir. So make sure that in this case that there are animals from this particular farm in the abattoir. In order to make inferences about a population, that population needs to be represented in the abattoir. So then the next question is, does the abattoir only contain animals coming from the abattoir population? So if it does, that's a very simple scenario. We'll look at the reverse in a minute, but if the abattoir only contains animals coming from this farm, or in a more complicated scenario from a region, then that's a very straightforward situation. Then is the target population animals, is their only destination this abattoir? So is there any possibility that they could go elsewhere to a different abattoir, or possibly to, if they die, go to a knackery facility or something along those lines? So in this situation, we're keeping it simple, and the only place that they can end up is this abattoir. And then finally, we ask ourselves, are all subcategories from the population, from the farm, proportionally represented in the abattoir? So are all the various groups represented in a proportional manner in the abattoir? So your heifers or your steers, your old animals, your young animals, are they all there? And again, we're saying yes in this situation. So that allows you to calculate your apparent prevalence. Because we've kept it so simple and straightforward here, your abattoir population basically is your study population. So it allows you to just have your total number of diseased animals that are found in the abattoir over the total number of animals in the abattoir. So then just going on to look at the more complicated situation. If the target population is not defined, we need to define the target population. And again, we define it in terms of location, animal type, and the time. We need to select our abattoir if it hasn't been selected. Then we look at whether target population animals are supplied to the abattoir. If they're not, then valid inferences cannot be made, and you can't go any further with it with an abattoir study like that. In order to make assumptions about a population, so if we're saying it's a farm, if there are no animals from that farm in this abattoir, you just can't make any valid inferences about that particular farm. But anyway, moving on, then we look at the abattoir, and ask if it only contains animals coming from a particular target population, so from this particular farm. If that doesn't happen, we need to exclude animals from outside the target population. Then we asked, our target population animals, is their only destination this abattoir? If that's not the case, then we need to ask ourselves a question. If they're going to different places, is the disease prevalence different in the various groups of animals? If it's not, then that's fine. We can just go on and ask ourselves the next question. But if it is, then we need to look at the two different groups and conduct a sensitivity analysis and revise our prevalence estimate. So just to look at how we would do that. So taking our very simple example, look at 300 animals on a farm. If we say that 80 of them go to an abattoir, and this abattoir is collecting information for us, 16 of them are found to be diseased, giving us an apparent prevalence of 0.2. But 20 other animals go to abattoir B, and in this case we look at abattoir B. It's not collecting information, but we assume that this group of animals is different, their apparent prevalence is going to be higher, perhaps they're older animals, they've been on pasture that's more likely to be exposed to fluke, and their apparent prevalence is somewhere between 0.3 and 0.5. So we need to include these animals in the calculation. So for the 0.3, we've got our 16 animals from abattoir A, 0.3 of 20 is 6, giving us an apparent prevalence of 0.22. And for the 0.5, something similar, 16, 10 animals from the second abattoir, giving us an apparent prevalence of 0.26. So we've got our revised apparent prevalence range up from 0.2 to 0.22 to 0.26. So then just back to our flowchart and moving on. We look at the subcategories of the animals in the target population and ask, are they proportionally represented? If they're not, we ask ourselves the same question, and is the disease prevalence different in the various subcategories? If not, things are quite it's relatively simple. We don't need to, the abattoir population is going to represent all the various subcategories. But if the disease prevalence is different, then we need to do a similar calculation to what we did the last time. And in the interest of time, I'm not going to go into that now, but it would be done in a similar manner. But then that allows us, once we've done that, that allows us to calculate our apparent prevalence for the target population. So, as we said earlier, our apparent prevalence is calculated from the study population. In this case, the study population is the abattoir population with a number of changes, so some animals possibly excluded, and maybe some animals added in, as in the example. So in the example, our apparent prevalence had been 0.2 and was revised to between 0.22 and 0.26. So the second flowchart then, looking at disease misclassification. First question, is the outcome defined? Once it is, in terms of the outcome, if we're talking about liver fluke, you may be looking at something like, are fluke seen in the liver? Is there fluke damage seen in the liver? Or are you talking about a combination of both? The important point is that you define what you mean. Then secondly, is the protocol for determination standardized? So in terms of liver fluke, the EU regulation sets down the way in which a liver should be examined. So we have a standardized protocol. And we ask ourselves, has it been validated? And we look for a sensitivity and specificity. And then you need to ask yourself whether local conditions are consistent with the conditions under which the validation was conducted. And I suppose you might be thinking about something like line speed and in an abattoir, and whether it is possible to look at livers in that time available. And from that then you're going to obtain your sensitivity and specificity. So with your apparent prevalence calculated from flowchart 1 and your sensitivity and specificity from flowchart 2, you can calculate your true prevalence using this formula. And just looking at the negatives then, if the outcome hasn't been defined, we need to define the outcome. The protocol for determination, if that has not been standardized, the protocol may not be particularly accurate. You may just not be able to find a sensitivity and specificity, and you need to just go back and look at the apparent prevalence you calculated and discuss in your study how useful this information is. The validation of the protocol, if it's not available, again, you could just use the apparent prevalence without looking at sensitivity and specificity and just discuss the limitations. Or you may be able to get some expert opinion on sensitivity and specificity and estimate some sort of range and conduct a sensitivity analysis, as we gave an example in the first part. Then we look at local conditions. If they're not compatible with how the protocol is conducted, you may use your apparent prevalence or possibly get some expert opinion. Or if you are lucky enough to have a validation for your protocol done under local conditions, well, that's one way of getting a sensitivity and specificity. So I suppose you need to then go on and calculate your true prevalence. You'll have your apparent prevalence from flowchart 1, your sensitivity and specificity from flowchart 2, and use it within this calculation to give yourself a true prevalence. If you have multiple values, you may well have to conduct a sensitivity analysis and identify a true prevalence range. I suppose just to say that we looked at some literature going back on abattoir surveys for fasciolosis over the last 10 years. In many of those, the target population hadn't been precisely identified, protocols not clearly outlined, and sensitivities and specificities were not given. So I suppose it just outlines the usefulness of an approach like this. And just to conclude, I suppose precise identification of target and study populations is vital. Defined outcome and protocol sensitivity and specificity is necessary. And once you have those things, and if there are any deficiencies identified, they need to be transparently reported and facilitate discussion on the effect on the prevalence values. Thank you very much.
I think we have time for one quick question. If not, then thank you very much.
Thanks. Thank you very much.